Okay, this is my network systems class presentation of a TCP protocol. A little TCP background and history. This protocol is used throughout the network model. Almost every operating system will support TCP. It was developed out of a Department of Defense contract to the research and was done at several universities and was a response for a network protocol that was open to multiple computer companies to use. Up until this point, it was based off of specific companies on what they used. So if you had one, like say an IBM, it wouldn't necessarily work with a Mac and vice versa. And so this allowed it to be more open, so it didn't matter what company you used, it could be used for any of them or most of them. TCP will start to become the popular choice by the 1990s, and today is the one most dominant. TCP was part of layer 4 of the OSI model transport layer. TCP is found on layer 4 of the OSI transport layer. The transport layer is where the data delivery happens. This happens between two endpoint hosts. So part of the TCP's functions are to use IP for the end-to-end data delivery and to provide services for the applications that are found at the endpoint computers. Another protocol on this level is the user datagram protocol, the UDP, is also found. But TCP is going to offer a broader set of services than a UDP. Just kind of continuing on, there are 5 principal features that TCP will support in this layer. The first one being the multiplex using parts. Second one being error recovery. Third one, flow control using windowing. 4, connection establishment and termination. And then the last one of this is going to be ordered data transfer and data segmentation. Multiplexing using parts. These parts function is to allow receiving hosts to choose the correct application for the destination of the data. This is based on port number. Multiplexing uses TCP will tell a computer receiving information which computer application needs to receive the data. So even if you have your computer open, all these different programs going, through TCP, it's going to tell the application, say you want to check a POP3 mail service, and you can do that, and TCP is going to say, this is where this is going, not to say, to the internet, World Wide Web. So those are things that it's doing in this. This is where the port number is in the header comes into play. Talk more about the header later on. Multiplexing has to have an IP address in a transport protocol, which this covers, and a port number. These are also known as a socket. And of course, TCP is going to play a role in that socket because that's that transport protocol. Error recovery was the second point, or the second set of the 5 principal features of TCP. This is a process of numbering and acknowledging data with sequence and acknowledgement header fields. Again, we'll cover that a little bit more here in just a minute. TCP will retransmit as a way to have error recovery to help fix some of the issues. If it can't, then obviously it's going to just not send it out. Or if the route isn't done just right, it'll drop it out if it cannot be fixed through error recovery. The way that TCP is able to do error recovery is through the use of the TCP numbers data bytes, as done through the sequence acknowledgement field found again in the header. The use of the sequence number fields at one end and the acknowledgement field at the other end is what helps with this. So you're going to start at one end and it goes to the other, so it can kind of go back, retransmit, and see if it can figure out what went wrong, pick it up, and then it goes on, hopefully to submit the information packet. Flow controlling using windowing. This is the third point, or the 5 that was discussed a minute ago. This is a process that uses window sizes to protect buffer space and routing devices from being overloaded with traffic. Sometimes you can get too much information, it bogs down, and things really don't work the way they're supposed to. So it kind of helps out with this. TCP has a flow control mechanism that controls how much data can go through at one time. Again, this is done through a window, so to speak. The window lets the end that is receiving tell the one who is sending how much to send at one time, so it doesn't get overloaded and things can run smoothly. At least that's the goal. And it can change this as needed, so it can kind of slide, kind of a sliding window, so to speak. So at one point, if you only need X amount to go through, but then you need a little more than it because things are freed up, then it'll allow a little more. So this is just kind of help, hopefully getting things through smoothly without a whole lot of wait time, so to speak. Connection establishment and termination. This is a process that uses initialize port numbers and sequence and acknowledgement fields, again in the header. Before anything can happen with the TCP, a connection has to be started. This is where the start of the sequence and acknowledgement come into play. Once a connection has been started, the sequence and acknowledgement fields and agreed port number will be used. This is known as the three-way handshake. So you have the syncing, which starts the connection, then you have sync again along with acknowledgement, and the acknowledgement just says, hey, yo, I've received this data, and then acknowledgement again. So it's like, okay, we're all good, everything's moving. And then there's even the textbook talks about a four-way, where it actually has a deal where you finalize and kind of ends the transmission. Order data transfer and data segmentation. This is a continuous stream of bytes from an upper layer process that is segmented from transmission and delivered to upper layer processes at the receiving device with bytes in the same order. So this is just making sure everything stays in the same order. Data is going to be sit in segments, but it's all going to stay. So basically what's at the front end is going to stay at the front end. So the back end is going to stay in the back end. What's in the middle is going to stay in the middle. And this just kind of makes sure that, okay, this goes first, then this, and so things hopefully don't get all jumbled up and errors occur. Now I told you to talk about the TCP header. This is where it's going to come into play. The TCP information header is made up of about 20 bytes of information. There are 10 parts to this header. The first 2 parts is where you're going to find the source destination ports. Also makes it, and this makes about 4 bytes out of that 20. The next step, the next part, which is the sequence number, is 4 bytes. We talked about the acknowledgement number. In the offset is going to be 4 bytes. The reserved is 3 bytes. And the flag bits can be up to 9 bytes of information depending on what is needed. The window, we talked about the sliding window, allows so much in at so much time to get things from bogged down. The checksum and urgent, each one of those are 2 bytes apiece. So if you add it up, it roughly comes into about 20 bytes of information. And I know that it can actually be more than that, depending on what other circumstances are part of the process. So I know our textbook had a nice, really neat little box, set it all up. But this kind of gives you a little bit of how this all is put together. And again, this all stays in the same sequence. Some of the more popular TCP applications or applications that use TCP are going to be File Transfer Protocol, Telenet, the World Wide Web. A lot of times you'll see TCP IP together. So they do work together on a lot of things. POP3 mail, to name a few. I know that cell phones are use TCP. I know I check my work email through my phone, which is a POP3. So thanks to TCP, I can do that, which is phenomenally awesome. But this is kind of my coverage of the TCP protocol for this class. A little bit of works cited. Most of my information, like I said, came mainly from the textbook. I looked at Chapter 1 for some of the background information, and most of it came out of Chapter 5. The information about the TCP header came from a website of LifeWire, and basically that just kind of helped me break down how many bytes total there was, and just how each part of the header dealt with, the 4 bytes to 2 bytes to up to 9 bytes. And so it just kind of helped me. Thank you for listening.